Hello everyone, today we will learn the finite welding on a T-joint in the horizontal position. In this lesson, you will learn the operational requirements for finite welding on T-joint in the horizontal position, how to develop a welding plan, how to select welding parameters, how to weld qualified components meeting requirements of welding safety, cleanliness, environment, and welding process, how to conduct a visual inspection of components according to standards. This is construction drawing of horizontal precision welding on T-joint. We can see from drawing that the material of the specimen in Q235. It consists of two steel plates, each 300 mm long, 150 mm wide, and 12 mm thick. The assembly angle is 90 degrees. T-joint is a common joint type. As the two plates have a certain angle, the fluidity of the deposited metal is limited, so a slightly higher welding current should be used to avoid defects such as snag in crewing, lack of infilling, etc. The current for the last bit of the cover layer should be slightly lower than that of for other bits, which prevents undercut and groove. Difficulties lie in keeping two right-angled edges of the weld symmetric and the weld flat. Since the fillet weld size is 10 mm, we use multi-layer, multi-pass welding and weld one bit in the bottom layer and two bits in the filling layer and three bits in the cover layer. In the following, we will learn the welding method and the process of this project according to steps of preparation, assembly, welding of the bottom, filling, and cover layers, and inspection. Before welding, we must prepare as follows. Firstly, safety check. Ensure that protective equipment is worn properly and in good condition. Clean up the work site. There must be no flammable and explosive articles. Secondly, welding machine preparation. Check whether welding machine cable, welding bar wire, welding clamp are properly connected and debug. Thirdly, auxiliary tools preparation. Prepare tools such as grinders, welding hammers, chisels, files, weld brushes, steel rulers, and weld inspection rulers. 4. Specimen preparation. Check the size of the specimens according to the drawing. Remove oil, grease, rust, and oxide from within 20 mm on both sides of the specimen parts to be welded until the metallic luster appears. This is specimen after grinding. 5. Welding materials preparation. According to the specimen material, we choose E5015 electrodes, diameter 3.2 mm, as it has better processing properties. The rods should be dried at 350 to 400 degrees Celsius before welding and keep warm for 1 to 2 hours. Use when needed. The next step is specimen assembly. First, pairing. Put the prepared plates on the assembly platform and draw assembly positioning line according to the construction drawing. Then, follow the lines and assemble the plates into a T shape without any gap between. Tack welds are at the back ends of the fillet welds and are 10 to 15 mm long. Ensure the standing plate and the base plate intersect at a 90 degrees angle. After tack welding, check assembly position, tack weld, and verticality of plates. This is the assembled specimen. Now let's learn how to weld the bottom layer. Place the assembled specimen horizontally on the platform and set the welding current at 111 to 112 A. Strike arc at the left end of the specimen, lower the arc, and weld it to the right end at a uniform speed. When welding the bottom layer, we move the rod straight across the hold a short arc length, which avoids defects such as snag in crewing, lack of infilling, etc. During welding, hold the electrode at a 65 to 80 degrees angle against the welding direction and at a 45 degrees angle to the standing plate. Move the rod stably at a uniform speed, which helps to keep the weld flat and straight. This is a schematic diagram of electrode angle when welding the bottom layer. Remember to fill the arc crater at the end. After the bottom layer is completed, clean the weld bed with a steel brush and a welding hammer. This is specimen with the bottom layer completed. Now, let's weld the thinner layer. We welded 2 beads on the thinner layer. Set the welding current at 100 to 120A. When welding the first bead, point the electrode to the fuel-in line between the base plate and the bottom bead. Hold the electrode at a 65 to 80 degree angle against the welding direction and at a 45 degree angle to the base plate. Move the electrode straight across at a stable and uniform speed. The bead should cover about 2/3 of the bottom bead to ensure complete fuel-in of the bead and the base plate as well as a neat edge. When welding the second bead, point the electrode to the upper fuel-in line of the first bead on the filling layer. Hold the electrode at a 45 degree to 50 degree angle to the base plate and at a 65 to 80 degrees angle against the welding direction. Weld at a uniform speed, but not too slowly to avoid undercut or overlap that affects the formation of weld bed. This is a schematic diagram of weld bed distribution and electrode angle in the thinner layer. After the thinner layer is completed, clean the weld bed with a steel brush and a welding hammer. This is specimen with the thinner layer completed. Now, let's proceed to the last step, welding the cover layer. The cover layer has 3 beads. Set the welding current at 111 and 120A. The welding method for each bead is basically the same as that for the thinner layer, but the requirements for the weld formation are higher. When welding the third bead, we muscled a short arc to avoid effects like porosity or snag including. The welding speed can be slightly faster to prevent molten metal from dripping down, which affects the fatness of the bead. If undercut appears in the upper fuel-in line of the third bead, we could weld another bead with a 2.5 mm electrode at 70 to 75A to eliminate the defects. After completing the cover layer, clean up the welding snag and spatter on the surface of the specimen. This is specimen with a covering layer completed. The key techniques of horizontal precision welding on a T-joint are as follows. First, successful welding depends on 30% on craft and 70% on current. When welding the bottom layer, the current should be appropriately high. Lead the slag to the rear of the molten pool with arc stiffness to avoid snag including. Second, in the multi-layer multi-pass welding procedure of the cover layer, the natural weld bit should cover at least 1/2 of the former weld bit to ensure neat formation of weld bit. After practice, we should organize tools and equipment. Turn off the power. Clean up the worksite and write welding records. The surface of the specimen must be cleaned up without traces of processing, grinding, or repairing. Then, inspection of improper fuel-in of weld, snag, surface, porosity, crack, the width of weld, echo-legs, undercut, verticality, mechanical damage, or arc abrasion, weld surface formation, etc. should be conducted by welders themselves, for welders, and professionals according to rating standards. Now we have finished the lesson, and I believe that you have already get a basic understanding of this welding operation. If you want to weld high-quality welds, you should be diligent in practice and keep exploring, reflecting, and summarizing during practice. That's all for today. Thank you.